Hello folks, my last video was blocked by the BBC. It was about this gentleman here. His name is Jim Al-Khalili, and he was discussing what nothing is, what space is, what vacuum is, and I analyzed his video. The BBC blocked it because they claimed that I borrowed or misappropriated or misused without authorization a few of their clips. These are a few of the clips that I used. Here's a quick rundown. Jim's conclusions regarding the Michelson-Morley interferometer experiment. Jim's inaccurate claim that Einstein's special relativity did away with the ether. This PhD's naive and mind-boggling assertion that you must take particles popping in from the void as proven truth. Jim's clarifying that Dirac's discovery of antimatter is today known as virtual particles under quantum field theory, okay? And Jim's conclusion that we came from nothing, after he made clear throughout his presentation that nothing is made of something. Okay, I believe that I had fair use of that material because I was using it for criticism. And I was using it in the scientific context. It was pertinent to the subject matter that I was addressing. And here is what fair use I'm using to back up my claim, and that's that it's okay to parody or comment on an original work protected under fair use. Okay, examples include showing short clips of a film while reviewing that movie, which is what I did. Okay, perfectly well. Or quoting from a celebrity in order to make fun of what they said. And I did a little bit of that as well, so both of them fall squarely within fair use. Now, I could challenge the ruling. I've learned through experience, my life, that you choose your battles, okay? And I thought it was better in this case to go in there, just edit the parts that Mr. Jim Al-Khalili talked, in which he appeared, and so I simply quoted him verbatim. I just did an voiceover, and I put new images for those same segments. And so I divided the video in two parts. The first part is going to deal with the question and answers that regarding the comments that people made, from the previous video, so it's got nothing to do with Jim Al-Khalili or with the BBC. And the second video, divided them in two videos, the second video will be dealing with Mr. Al-Khalili's arguments about the vacuum. Okay, and essentially, again, I did a voice over his segments, I put new images, and I divided them in two videos. So here goes. Enjoy. Hello everyone, how's everybody doing? I hope everybody's doing fine. Better than me. Okay, we have some fan mail. I'm going to get right to it because we have an interesting day today. We're going to be dealing with Mr. Jim Al-Khalili. Al-Khalili. But he does have some fizz. So yeah, let's get on with the fan mail here. Let's find out what people want to know, want to understand, okay? And one fellow asks, I do not exclude genetics from the possible causes of autism syndrome disorder, okay? However, it certainly does not justify a genetic deterioration of one child every 45 with ASD today. And the trend is pejorative and very rapid. Yeah, well, I agree. I think I don't know the numbers. All I have this feeling that autism is increasing. More kids are born. Good evening. Yeah, more kids are born. Both with, like I discussed a couple weeks ago, with autism and homosexuality. Personally, I think those are two mental disorders. They're not as severe as Down syndrome or Cohen syndrome, which is what the Amish are having. But yeah, I think it's on the rise. And so why is it on the rise? In other words, we got to look at the reasons, the causes. And what I'm saying is, I can't tell you all the little details that go into it, but I suspect, strongly suspect, that humans have lost their genetic diversity, as I've shown in a couple, or argued in a couple videos ago. And the reason for that is we've been inbreeding for hundreds of thousands of years. And yeah, after 200,000 years of inbreeding, you can expect some problems to arise, in a species, especially our species, okay? And so, yeah, I don't know. I think these disorders, they're mental, yeah, but again, mental comes from the brain. So we've had the situation with the Amish where you have a much faster process of what has happened to all of humanity. And that process, what it shows is that in 300 years, they're having some genetic problems, not only physical, because when you look at a physical problem, you say, well, yeah, that's obviously genetic. Yeah, but when you see a mental problem, then people get into these arguments like, is that genetic, or is that, the food we eat? Is it the environment? Is it how his mother raised them, et cetera, et cetera, So, no, I think a lot of this, at least number one ingredient should be genetics. That's my take, okay? 5 cents worth, okay? Okay, let's move on. Here's another comment. It says, whether someone thinks humans are natural carnivores or not seems to always have something to do with what they like to eat. I don't think so. I like to eat meat. I eat pig, like I said. I love pig. I'll eat its tail, its hoofs. I'll eat whatever the pig has because I love every part of it. Is that why I think that humans are natural-born carnivores? No, I have a different version, and this is my argument, okay? You can take it or leave it, do whatever you want with it. We've been on Earth, our species, maybe 200, 300,000 years, meaning that if you marry someone beyond that time, you won't have any fertile offspring. That's essentially what I mean by species, okay? That you would not be able to have valid offspring, in other words, fertile offspring after a certain time in the past. Okay, we can't have children with whoever was our ancestor a million years ago. That's my point. And for at least 200, 300,000 years, even before that, I think we were hunters, primarily hunters, not gatherers, but hunters. I don't know what we could have gathered, maybe fruits and nuts. That's the only thing I can think of. I don't think we ate lettuce out there, okay? Assuming there were some kind of ancient lettuce of some kind. I think we were primarily meat eaters. And we were meat eaters for many, many thousands of years. We only became veggie eaters, net veggie eaters, when we started to settle down, when we formed farms and little villages. And that was maybe a little before the Neolithic and primarily during the Neolithic. So, no, my take is not, it has nothing to do with what I eat. It's got to do with the fact that we've been hunting for at least 200,000 years. And I think it's that the fact that we've adapted our stomachs, whatever bacteria, whatever thing we have in there that helps us dilute acids. It's all a lengthy process where we just primarily ate meat. Maybe that's the only thing we ate. I don't know, Maybe some clans in the old days, they maybe only ate meat. Others may have eaten some veggies like nuts and fruits. I don't know. We don't know, or fish. Well, that's meat as well. So that's my take on it. It's got nothing to do with my preferences. Okay, so I just want you to know my side of the story. Okay, that's all. Okay, let's get on to another topic here. And one fellow says, if you have no evidence, then you are not doing physics, but just theorizing out of the blue. Well, theorizing out of the blue is what's known as physics. It's what's known as science. So-called theoretical physics, that is science. That's not philosophy, okay? The issue here is this fellow seems to think that you need evidence. Evidence is only used to convince people, to persuade even yourself, okay? So you look for evidence to see if you will believe something. Change your beliefs or confirm your beliefs, one or the other. But it's got to do with belief, with opinion. That's not science. Science should be objective, should be the same for everyone on earth. We should not have opinions in science. Opinions, religion, that's Sunday school. Science, you need to explain something objectively so that everybody's on the same page. Whether they agree with it or not is irrelevant, but everybody's on the same page. And that's a mechanism. So evidence is not about mechanisms, okay? Mechanisms, I explain a mechanism, maybe how a car works, you know? And you say, well, where's your evidence? Well, there's my car. No, evidence doesn't play a role. Doesn't play any role whatsoever in convincing and persuading people, okay? Okay, so that's my 5 cents worth on that as well, okay? Another comment. And yeah, some people are unwilling to change their opinion of what they learn in high school and college, that it's all about evidence. Oh, where's your evidence? Oh, I have to verify your experiment and all this kind of stuff. No. Science is about, explain to me a mechanism. What do you propose? How do you think Mother Nature runs her universe, especially her invisible stuff? How does she run magnetism? How does she run gravity? That's what people want to know. And so we exchange theories. And so someone says, look, this is the mechanism I propose, particles, for example. The other guy says, no, I propose waves. What do I propose? I propose ropes. I'm saying everything's interconnected. So everybody proposes a different theory, a different explanation. Then everybody goes home. Science class is over. Science conference is over. Everybody goes home and just reaches his own conclusion of what he thinks is out there. Okay, that's it. But this thing about, oh, where's your evidence? Well, I don't have any evidence. How's that for science, okay? You want evidence, you got to come to Sunday school, and I'll give you all the evidence you want, okay? Okay, could you help me understand the difference between science and technology? Well, I've got a good one-liner here. It comes from a very famous individual, and his name was Thomas Alva Edison, okay? Edison, he said, and he was a very important inventor, probably more a businessman or just as much as an inventor, but because he had a lot of people working for him. And this is out of the Wikipedia, what you see there. Here you see, it says, one of the first inventors to apply the principles of organized science and teamwork to the process of invention. You know, people like Henry Ford and Edison, they started doing stuff along mass production. And they had teams that worked on inventions, so they were able to advance quite quickly and make a lot of money. And yeah, he established the first industrial research laboratory. But what I like about what he said, he says, I have not failed. I've just found 10,000 ways that won't work. And he may, I don't know what the context was, but I think that he may have been referring to you know, he developed a filament that was marketable, right? And so that's what he's credited for primarily, you know, the Edison light bulb. That was modified years later in many ways, but he was the first one that made something that was practical as a light bulb, and that replaced all the candles. And Ford had to, Rockefeller had to go into oil but sell it to something else. First he sold oil for heating and so on and lighting, and then he had to sell oil for what? For the car that came after that. Then he made money. But anyways, yeah, Edison said it properly. He said, look, it's all trial and error. You know, I worked in the industry for many years, and in manufacturing, and I was directly in manufacturing in the side what you call technology. I was not into science. I was into technology. I had to develop processes to make them better, improve them, etc., keep control. And, you know, you do a lot of that stuff In fact, I'd say all of it, by trial and error. Nuclear weapons, trial and error. Some people say, oh, these mathematicians, they came up with the equation. Trial and error. They went to the lab, they bombarded things at high speeds that they could not see, and they reached certain conclusions about how much energy, how much mass, how much charge, and eventually they figured out that there was a lot of energy, whatever energy is, packed inside that atom. And so based on their very vague understanding of the invisible world, they still were able to develop the bomb, but it wasn't the mathematicians who developed the bomb. It was the guys who worked in, you know, for example, in this case, in Alamo, over there in what is it, in New Mexico. You know, they had a military installation essentially, and they developed it by trial and error. How? I mean, here you have the Iranians, and they have they know a lot of math. They know as much math as anybody on the planet. They don't have a bomb. Now, you figure that out, why? I mean, shouldn't it be straightforward if you got the equation, right? It's a done deal, right? No. You need trial and error. And so technology is one thing, and that's developing gadgets and by trial and error. And science is about explaining mechanisms, okay? And until you get that underneath your belt, you know, you're going to have a little bit of problem trying to figure what science is. Okay, here's another question along similar lines, I guess. If science isn't about experiments, then what purpose do experiments serve? Okay, experiments don't do anything for us as far as science is concerned. But you can run an experiment on your own or with a team or whatever, and you know, maybe get clues out of that. Okay, you get clues and you get an idea of what you propose theories in your mind. You brainstorm theories, explanations. You say, well, how does this work? You know, magnetism, just as an example. So you look at magnetism, you say, how does magnetism work? How does a magnet attract another from a distance? Well, this guy comes up and says, well, maybe it's particles. They're pushing the magnets together. Another guy might say angels. Maybe it's the angels that are holding hands and pulling on each other. And another guy, like me, who says, well, maybe it's threads. You know, you have the threads, they pull and then they push, okay? So there are different theories, and that's it. That's but you don't need to run an experiment. The experiment only maybe reinforces your theory, because you say, well, it looks like I'm looking at this experiment, it looks like it confirms everything that I believe, my argument, my theory. Fine. You know, and that's the purpose of an experiment. But when you go to a conference, you know, the point of the conference is to explain not what you did, just say, well, this is what I did. You know, I threw the rock 100 times and it always fell to the floor. Oh, great. You know, great presentation. You described that you threw the rock. And you might even put an equation, say, well, you know, or a number or whatever. And you say, well, you know, the rock fell at certain acceleration. So, what have you explained? All you did is tell the world about a measurement that you made, and that's it. No, you go to the conference to explain something, not to explain what you did, just, you know, just a chronological step-by-step process of how you came about your ideas. No, you got to explain your idea. That's what people want to hear. They want to hear your theory, your explanation. And so, yeah, experiment, nothing wrong with experiment. I do experiments myself. And again, what do I do them for? To try to confirm if there's anything wrong with the theory that I propose for that experiment. You know, if you see something out of the ordinary, you say, oh, hold it, I got to withhold my theory because here I can't explain this part of the experiment. But that's got nothing to do with presenting an experiment as evidence to convince the jury. That's a totally different process. That's persuasion. Okay? Again, experiments, no evidence. We don't use that in science. That's only in religion. That's to try to convince the jury. Okay, let's move on here. Another question or topic. Fellow says, scientific method has 5 basic steps, plus 1 feedback step. Okay, make an observation, ask a question, form a hypothesis or testable explanation. Okay, make a prediction based on the hypothesis, test the prediction, And then the feedback step, iterate, use the results to make a new hypothesis or prediction. Okay, the three basic principles to determine a hypothesis is correct, okay, shown by experimenting with consistent results. It meets the observation. It is experienced. Okay, what is wrong with all of this? Is this a scientific method? Well, it's the one we learn in high school, in college, you know, and I'm going to challenge it completely, but I'm going to address only three issues essentially, okay? And here it is. Okay, the first one is that what he described here is a process of investigation. It's how you do research, not science, okay? Science is not research, research is not science. Those are two different things. Science is explaining at the conference what you found out, not how you came about your ideas, okay? If you want to introduce that as an anecdote, that's fine. It says nothing about how the universe works, okay? In other words, these 5 basic steps, it doesn't tell you anything about how the universe works. It just says this is the process to do an investigation, you know, a research. That's all he's saying. And there's no provision in there, as you can see, for objects or definitions. But here I like the the comment that he made, and he makes this comment, the one on the right in red, in the second bracket there, that is his comment, okay? And you see how he's got a contradiction. He doesn't even understand that he's got that contradiction, and this is the contradiction throughout all of mathematical physics, throughout the science world. And here it is. He says, from a hypothesis or testable form a hypothesis or a testable explanation, right? And when he goes to the right, you don't see the explanation at all. He says, when you drop the rock, you have tested experiment, okay? Will the rock drop or float? Okay, so far we understand what he's saying. He's saying you let go of the rock, it might fall to the floor or it can float, okay? When the rock drops consistently, it's observed and experienced. It's a correct hypothesis. I thought a hypothesis was a testable explanation. All he's saying is he's got a description, and again, all these people don't understand the difference between an explanation and a description. An explanation is tell me why the rock falls, what causes the rock to fall. A description is, oh, the rock fell instead of floating. Okay, so he's got no explanation, but he calls both of them a hypothesis. You see the problem there? And then the other issue down at the bottom, also his comment on the right, he talks about correct, a hypothesis being correct. And he says, suppose my shop tools are just slightly out of place every once in a while. I have 2 hypotheses, okay? In other words, he's got 2 theories, but he calls them hypotheses, okay? One, that my son is sneaking into where he's not allowed. 2, it's a pink unicorn screwing with me. If it's the son, I assume he is lying when asked. If it's the pink uniform, I have to assume about 1,000 things. Right out of the gate, the pink unicorn hypothesis is incorrect, having far more assumptions. Occam's razor, the more assumptions you have to make, the more unlikely an explanation. So the first thing is correct. Correct is an opinion. That's the first issue. Okay, and I have an opinion, and my opinion is I'm going to insist on the pink uniform. I think it's the unicorn that's doing all this stuff and not your son. And you can present all the evidence you want. You can bring God into the picture. You can bring equations, whatever you want. And at the end of it, I'm going to say, I still believe in the pink uniform. Now, which of us two is correct? And no matter what evidence you bring, what you do, you stand on your head, I'm going to insist on the pink unicorn. Okay? So, correct, does God exist? Who's correct? An atheist or a theist? So we have to put it in the right perspective. No, in science we are not correct, incorrect. We are not true or false. We are not, right or wrong. In science we are rational. You present a rational explanation. You did science. People understand the theory you're proposing, the mechanism. We're done with science. Whether it's correct or not for you, that's Sunday school stuff. That's belief. That's opinion. Okay? So, the problem is we're taught this by rote in high school and college, and then people can't get out of this hypnotism that they're in. They say, oh no, it's It's evidence. No, it's hypothesis, which is what? Description or a theory? Is it a description or an explanation? Which is it? And they don't understand the difference between a description. That's why we had to define these words, description and explanation. Okay, another one here. Another comment says, there is a scientific dictionary, okay? It's a list of terms used in science. In it, no one is trying to change the definition of words we use to communicate with. These words are used to describe what term is being defined with, okay? And so I got some homework for this fall. And here's the homework, okay? Go to your dictionary and look up these words for me, please. Something. What is something? What is location? What is nothing also, by the way? Exist. What do you mean by exist? I mean, we use the word something or say thing or object or a medium or entity. We use them constantly in physics. And the other one is exist. Those two words, you can't live without them in physics. And nobody's defined them. So as far as I know, there's no definition, but go to your science book and science dictionary and please come out with a definition for those words. What is energy? We don't have a definition for energy. We don't have a definition for mass or field, you know. And what is a point? I thought everybody says that the point cannot be defined. Well, I need to know what a point is, okay? And then we have space-time. What is space-time? Can you define that? Is it an object or a concept? What is a wave? Is there such a thing? Black hole? Anybody have any idea what a black hole is? I have yet to find a definition. And I don't know, maybe he might consider that these are not scientific words according to him, but you know, these are words that are kicked around in the so-called scientific literature. So they should be in that dictionary. So please find definitions for those, and then we'll find out if there is a scientific definition for those words, okay? Okay, next comment. If I can get it up here. Okay, what is this? Says, try looking up possible roots of shape, which is Kepne, Icelandic, and Skappan, and he goes through all these origins of the word, you know, etymology. And he ends and he says, because all these, he says they all mean create, manufacture, words to that effect. And then he says shape is a verb. Well, you know, we don't care about the origin of words in this sense here. Our ancestors had a lot of misconceptions that we've corrected over the years. So the origin of the word shape is irrelevant in this context here. The word shape is a static concept today. It's not a verb, okay? Shape is a property of objects. And it's the only universal property, the one that all objects have. It's the only one. Not all objects have other properties, and especially static properties such as shape, which is a contrast, essentially. So here, let's see, I've got this. Here's to show you that shape is static, okay? Is there anything moving in that picture? No, there's only contrast. And we don't even need you. If there's an object in the universe, let's assume a three-dimensional object, one that's out there, the moon before humans came to be, okay? There was a moon out there. There was no observer of the moon perhaps at some point in time, and if you go back in time as much as possible, right? At some point there was no living entity to contemplate the moon. Well, the moon still had shape. Hopefully. Okay, the moon's been around, I think, for quite a while. And so if the moon had shape, it had shape irrespective of the observer first, and second, irrespective of motion. All we have is a contrast between the moon and what's in the background. If we're trying to visualize it, imagine it, it's got to be against space as a background. So no, shape is not creation. Not anymore, at least. Maybe that was the origin, but it's irrelevant today. Okay, another one here. Another one related to shape. Okay, and here it is. A little lengthy. I'll just go through it quickly. If I can get it down. Okay, I would have to conceive of a sphere as appearing in front of a backdrop. Exactly, right? You have to have something serving as the background, the backdrop, or the contour, whatever you want to call it. or canvas that creates a contrast between the shape and color of the sphere and the backdrop or canvas. I guess he's referring to the four-dimensional space-time here, thus rendering the sphere conceivable, or the hypersphere, maybe. This backdrop or canvas is not itself infinite. Yeah, hopefully not, because in the case of space, it's not an object. And you can only use the word infinite in the context of object. You can say an object is infinite, which is a contradiction. It's an oxymoron, because all objects are finite, okay? But then if it's so-called infinite, it's not an object, okay? It's not an object, and that's the key issue here, okay? Okay, this backdrop is not itself infinite in my mind. Yeah, that is nonsense. However, this backdrop or canvas is absolutely necessary in order to conceive of the sphere. Yeah, correct. This is why any notion of curved space that is unbounded yet infinite is an absurd conception. Yeah, and here, let me just illustrate that real quickly. If I can find it here, where is it? Here it is. Here you have the hypersphere, okay? Sorry, the hypercube. And no matter how you want to look at it, you can even look at it in static mode. It's got to have something to give it shape from the background, and that's going to be what we call space. And is that black stuff limited? Is it finite? No, because it's not an object. That's why. It's not a physical thing like that thing that's rolling there. Okay, so space is not an object. Space is nothing, and we have to define those things that are not. In other words, those words which are not things. And everything in the dictionary is either a thing or a concept. Those that are concepts, you have to define them. You can't point to them. You can point to every object. You can point to a horse, you can point to a rock, a house, whatever, fish, but you can't point to a concept. You can't point to love. There's no such thing as love out there, okay? Love is a process, feeling, okay? There is no love out there. Mother Nature did not create love and say, okay, here, I'm going to give love to humans like she gave fire or whatever, even though fire is also a concept, but a process, right? Combustion. But the issue here is that, it's either concept or an object. It's one or the other. Every word in the dictionary falls under one of those two categories. Either it has shape or it doesn't. Period. We're done. And and so here we have. And so space is a concept because it means it's a synonym of something we're going to talk about today, which is nothing. We're going to talk about nothing today. Not anything, but nothing. And here's a little picture that also puts this in perspective. Here's God, and that's God in space, okay? And what happens if we remove space, we remove his background? Well, that's God. God disappears because he's got nothing to compare him against. He's not an object anymore. He's suddenly become a concept because we removed the space, whatever gave him background or whatever served as a backdrop, as the stage in which God was in. Okay, so yeah, you need to have a backdrop for any object. And again, every time you think of an object, you got to think of it as the only object in the universe. As soon as you introduce something else, you're going to get into trouble. Because then you're going to look at relations, you're going to look at motion, you're going to talk about a lot of nonsense that has nothing to do with shape. Shape, you point to, if you want to present the object in physics, and it better have a backdrop. And typically, if it's the only object in the universe, then it's space and the object. That's all that should be in front of your eyes. And you point to it, people give it a name, and people understand what you're talking about. Straightforward. Okay, none of this nonsense about moving space-time and wiggling waves and zero-dimensional particles and all that nonsense. No, you point and name. That's it. And you can't point to a wave, for sure. Another comment here. Says the analogy of the cotton fibers. Okay, I did the analogy the other day, try to give you an idea why the threads do not blend or go through each other when they form the rope, which is a very good question, okay, by the way. And I can only give you my thought on that, okay? I don't know Mother Nature's exact secret. I try to brainstorm ideas of how she does this. Okay, so it's not like I've got this settled even in my mind. Okay, all I can do is give you analogies of where I'm coming from, you know, my way of thinking on this. And I said, well, one way of looking at it is if you have a cotton, you know, piece of cotton, a strip of cotton, you pull it apart very easily. But if you roll it one around the other, well, it's a little harder to pull apart. And I think more or less that's what's happening with the threads and the rope. Once you wind them around, instead of going through each other, what they do is they like press against each other somehow, okay, and they don't go through. And that's all I can tell you. I mean, this is the only way I can visualize this for Mother Nature. And okay, so he says, this idea introduces a new unexplained property of the thread in the rope hypothesis. No, it is explained, so I don't know why he says that it's unexplained. There is an explanation. You may not agree with the explanation, that's a different story, but there is an explanation. And so first let's deal with that. First, you need to know what an explanation is, okay? And here we define the word explanation scientifically because people confuse it with description, like this fellow before that confused hypothesis with theory. The causes or reasons, I'll skip philosophy, the causes underlying a phenomenon, okay? How a consummated event happened, okay? And you give an explanation, I gave an explanation, so we do have an explanation for how it is. Now, you may not agree with it, or you may find flaws in the explanation. Fine, that's a separate issue. But to say that I did not explain is wrong. Okay, and you know, there is an explanation. Then he says, let's get this one out of here for a second. He says that they are not fully intangible. Correct. I think they're not fully intangible. Remember, the thread is three-dimensional at a very, very small, tiny, thin, vanishingly whatever level. Okay, we're talking about something extremely, unimaginably thin, or has no width almost. Okay, so from our macro perspective, right? Okay, so are they completely intangible? I would say no, they're not. And in my book, I explain the conditions under which the thread becomes tangible, and it's got to do with aggregation. Okay, just quickly here. And it says, but barely tangible, so that two individual threads can blend practically unimpeded by imperceptible friction. Yeah. This friction does not add up in the case of the blending of uncountable magnetic threads sweeping as paddles. Why not? No explanation for that. Why it doesn't add up. Yeah, I'm saying that aggregation forms a paddle, essentially gazillions of paddles just rolling around from one magnet and the other magnet. When they clash, they push each other away. When they go in the opposite direction, they attract. So one of them, you know. I don't know what the problem is. Yeah, it's friction, and the more threads that intervene, the faster two magnets come together. So I don't know what this fellow doesn't understand. Okay, that's one issue. What is the nature of this friction? Friction is friction is friction. Do you know what friction is? Friction means that there's some rubbing or something at very fundamental level, if we're going to talk about the thread. Okay. So you're asking a question that has no answer. You just have a definition of friction. That's all. That's what the nature of friction is. Friction is rubbing. So I don't know what the nature that you're referring to. What are you trying to find out? What's your question? Okay. Is this the same friction that aggregates in the pulsating electron shell, which you say is the physical interpretation of electric charge? I think this is irrational. Well, before we can deal with the word irrational, we need to know what that word means. And it's easy to say, dismiss something that violates your religion as irrational. So what we do in science, we define the word irrational. We had to because people accuse others of being rational or irrational, and nobody knows what they're talking about. So here we define what we mean by irrational. Treating concepts as objects, that's the main one, reification or concretization, which is what mathematical physics does with terms such as energy and mass and field. They turn them into objects. Using inconsistent definitions, theory is inconsistent with or doesn't follow from the assumptions, describing especially mathematically and claiming to have explained. None of these fall under what he said right now is irrational. Now, the last one could. He says, mechanism proposed doesn't work or cannot be imagined. So I think this is what he's referring to maybe when he says irrational. And again, I don't want to second guess him or put words in his mouth. This is what apparently he's referring to. Well, I'm not sure what part he doesn't imagine. And that's for him to clarify, not for me to try to put words in his mouth. Okay. What I'm saying again is if the thread is pulled outwards, it tends to, it's only pressing against the other thread when it's building the rope. Whereas when two threads come across each other, moving across each other, then they don't form that element. In other words, now they're not pulled perpendicular to that motion. Okay, so going across is not the same thing as being pulled by the atoms, taught in a tightly stretched, it's not stretched, but it's pulled taut, so that you can, if you were Atom Man, you could walk upon that, because it's like a board or a steel beam or whatever. It's very tight, okay? And the other comment that I want to say about this is that, a lot of these people, I don't know this fellow, but a lot of people ask a lot of questions regarding, again, see touch. You can see all the questions are see touch, the nature of the rope, the nature of the thread, what properties it has. So, and all the questions are related to see and touch, okay? A lot of these people don't ask those same questions for quantum. See, the problem here is that people say, oh, Bill, I don't like the answer you gave to this question, so I'm going back to particles. I'm going back to quantum. And here's where we have a problem. See, you can't go back to quantum. There's only two possibilities in the universe. Either you do everything with particles, discrete particles. Waves is particles as well, okay? Waves is the movement of particles, okay? So no matter how you twist and turn in, whenever you talk about waves, you're talking about particles. And that's what's always been the case for the last 10,000 years. They just talked about particles, the ether, and they just gave new names for the ether, space-time, the false vacuum, virtual particles coming in from what? The space. So space is not empty, et cetera, et cetera, et cetera. What are they talking about? Particles. And then they say, well, every particle is a wave and every wave is a bunch of particles. So it's always been particles. And right now we're proposing something different. We're saying all atoms are interconnected, and now you can explain action at a distance because there is no action at a distance. There is something there we can't see or touch, okay? So all you have is either the rope, which does pull and push, or you have particles, which can only do push. Half of the forces in the universe, half of the phenomena, pull, you cannot explain with particles. You have to do it through push, through pressure, through, you got to turn it around because you can't do pull with particles. And so this is the issue. You can either go with something between the atoms, or you can go with all these particles, all discrete particles, not even touching each other, okay, just floating around in space. Those are the only two options. And so if you're going to do it with particles, you got to answer these same questions. I mean, you got more idiocy, or like this fellow said, more, what is it? More assumptions. I can't even call them assumptions, they're idiocy. In quantum, a particle can be at two places at once. Nobody questions that. Two particles can be at the same place. Not two particles. A gazillion particles can be at the same place at once. So when I say the rope goes right through each other, say, oh, how do you do that? Well, how do you do it with particles? I mean, with the particles, they say the same thing, but you never ask the question, or don't seem to question, and you just say, oh, if you can't answer that question, Bill, I'm going back to particles. Particles is the same thing. You got to explain how two particles can be in the same place at the same time. But they have more idiocy, like a particle can be at two places at once. Now that's idiocy. There's no way you can even justify that. And of course, in the rope model, we don't have such nonsense. But if you're going to talk about the rope, first thing you got to do is, what do you propose in its stead. And if you're going to propose particles, I'm going to ask you the same question. If you can't answer it, well, you got no case. And if you got a third version that's not rope or particles, which I cannot imagine because there's only, either pressure or pull, then it's up to you to come up with your theory. Okay, so yeah, people, before they can criticize, they got to show their hand. Science is not about criticizing. Science is about explaining objectively a mechanism. So if you want to be a scientist, don't just come and criticize. Show your hand. I want to see your cards. Okay? People don't like to do that. Say, oh, I'm going to destroy your theory without showing my cards. No, not in science. Science, you got to have a theory to oppose it, because we're all in this conference room. 8 billion people are in this conference room. You can't, and the doors are locked. No one can leave until we have a solution. So you can't say, well, I'm just going to criticize your theory and leave. No, you didn't do science then. You want to do science, you're not a scientist. All you have is a belief. And so if you want to criticize, you got to have a theory to contrast it. Don't just call irrational what is inventing the word, because I don't know what definition this fellow has, but you can't just call something irrational without defining the word irrational and specifically stating what it is that you think is irrational about it. Not just say, well, here's a process that you don't understand or that you don't think you can imagine, and so you're going to call it irrational. Well, I don't know. We need to figure out what it is that you don't understand about what I'm explaining. Now, whether you believe it or not has nothing to do with rationality, okay? That's my 5 cents worth on that. And so here we have, here's the rope atom, okay? 2-dimensional and 3-dimensional versions of it. You have all the ropes in the universe converging on the electron shell, which is that ring there. And that's where the ropes fork out. One goes around, we'll call that arbitrarily the magnetic thread. The other one goes through and goes right through the center of the atom, out the other end or in some other end, not necessarily exactly straight to the other side. And there you have my good friend Dan Ferguson's version of the 3-dimensional version of the atom, okay? And here we have what this fellow was talking about. He's saying, how do you do this friction at the boundary of the electron shell? And yeah, we call that charge, the aggregate of friction all around the electron shell. Okay, here it starts. Give me a second. The atom quantum jumps, and what you have is light going out. They call this light energy. Okay, again, these are words that they use that they've never defined. And what happens is, as the shell goes back and forth, it creates this tiny friction between the two threads there, and that's what we're going to call charge, especially the aggregate all around the atom. Now, do you believe in this? Well, I don't care if you believe. The question is, did you understand the mechanism that I'm proposing for the word charge? And if not, well, there you have a picture. I don't know what else to put there. But if you disagree, well, all you have to do is present your version. And hopefully you can do it with particles, because that's much easier to destroy, to tear down. Okay, another issue. I think this same fellow brought this up about the magnet. And it says, I do understand the mechanism of the bar magnet, but I don't understand what keeps it in perpetual motion. There's no such thing as perpetual motion except in the universe. I put that in my book, by the way. The universe is the only perpetual machine. Why? Because space is not a thing. And so, at least under the rope model, you have a single thread, turns into all the atoms and ropes that interconnect them. And it's constantly in motion. Everything's in motion. I don't think you can stop all those atoms in the universe from moving. Okay, I cannot imagine it coming to a standstill. But that's me. You might think that in trillions and trillions of years, it all comes into a ball and then it starts again like an oscillating universe. Fine, I put that in the book as well as an idea. I personally don't accept that, don't believe in that. I think that galaxies will be there forever, and atoms will just be moving with respect to other atoms, and I think that is the nature of our universe. So I don't believe in perpetual motion. No, every magnet in the universe, including electromagnets and high-powered magnets, they all lose their magnetic fields. And I think you want evidence, you want proof. Here you have it. All those stones out there in outer space, moons, satellites that do not have a magnetic field, they lost it. After trillions and trillions of years, they lost their magnetic field. And I think eventually the Earth is going to lose its magnetic field too, long after we're gone, right? And the Earth won't have a magnetic field, much less will any magnet within the Earth have a magnetic field. At some point, all these magnets will lose their magnetism. So there is no perpetual motion. But then what we have to do is find out what it is that's moving perpetually, with quotations on perpetually, right? And those are the threads. And it says, I agree that not every possible phenomenon under the given model belongs in said model's introductory book. Okay, thank you. But bar magnets are a classic classroom example and one that you use all the time. Yes, I do. Both in your animations and on camera. And so deserve special attention, which I gave. But I could not find any in your videos as far as I looked. Well, I don't know. I have several videos talking about magnets and how they work, so I don't know. This guy missed them. I don't know. Here is, just in case, this is the quick version. Okay, we have two magnets on the left and two magnets on the right, which we're turning around there. And the one on the left is attraction, the one on the right is repulsion. And it gives you an idea how two magnets attract and how two magnets oppose or repulse each other. And I'm not sure what a person cannot understand about the mechanism that I'm proposing here. It should be straightforward. Okay, I'm not going to go in detail with it, but I have several videos on magnets that explains, I think, in quite a bit of detail. In other words, through pictures, right? So, some people maybe have trouble looking at pictures. Maybe they want words. Maybe they want equations. I have no idea. I'm giving you a picture of how a magnet attracts another from a distance. And hopefully there's something between the two magnets. And hopefully that something is not particles. It's threads, okay? That's my 5 cents worth. Again, my religion, okay? Okay, also with magnets here. Here we have it. It says, I think we both agree that there is no source of electricity in a bar magnet. Yes and no. It's somewhat complicated. Okay, I'm not going to go through the whole deal right here. Let's just go step by step here. Let's find out what electricity is. And according to quantum mechanics, and what they teach out there in electronics and electricity, all these electricians out there, this is what you'll find. They'll teach you that, electricity is just a flow of beads. What are these beads? They're electrons. So there are electrons in the valence shells, which are ionized and then are forced somehow by remote control. They're forced to move, okay? And so they move from atom to atom. Alternating current, well, you can see that it changes polarity for who knows what reason, okay? And they use this positive negative, which is only a mathematical gibberish. It has no physical interpretation. They always explain voltage as, a flow of water from high potential to low potential, and that's it. That's all they can do, and it's always the same analogy. And the water represents the electrons there, okay? So that's it. What is the rope version of this, of electricity? Well, here's the rope version, okay? It's torsion, okay? But what you have is electron shells which are bound to each other, okay? So all the valence shells of these atoms are blended into each other, and they form these long rows of electron shells. I call it a serpentine. And this serpentine twirls in place, okay? Alternating current, all we're doing is changing clockwise to counterclockwise, okay? And Mother Nature understands clockwise and counterclockwise. Mother Nature does not understand positive or negative. Those are things that we invented, and they're mathematical concepts that have nothing to do with physics, okay? positive and negative have, you know, how do you convert that into physics? And they never have. Obviously, they just keep using the words positive and negative without understanding what they are talking about. Okay, and here's another version. Here you have the serpentine there twirling, and when it does so, electricity is into your eyes, and the threads which form the magnetic field sweep 90 degrees to it, consistent with our experience. In the case of quantum mechanics, which is on the left, all you have is these charges, negative charges, whatever those are. And electrons, are they real? I don't know. According to quantum mechanics, they're not even real. They don't have any body, so we don't have an object, you know. So, and that's their version. It's just a flow of charges. And why it's got these rings around it, that field, nobody knows, not in quantum. In our case, we can see why the threads spinning around form the, not only form the magnetic field, but also cause a force, because now you have a real entity, invisible, intangible entity, which some objects can detect, but we can't, okay? And it pushes, and when it pushes, we call that a force. Okay, so that magnetic field had better be something, otherwise you're putting an angel, a spirit, or God's magic in that same space. Okay, so, you know, hopefully we have a physical object if we're going to do physics. If you're going to do religion, yeah, you can do it with magic wand.